Hello everybody, and welcome to this first debriefing session of the Copernicus Marine Online Training Workshop dedicated to the Iberian and Biscay and Island region. So I'm Vincent Legros, Marketing Officer for Mercator Ocean International. I am with Josefina Lusto from Plocan, who will be the moderator of today. Hello, Josefina.
Hello, Vincent. How are you?
I'm good. You? I hope so.
Fine, thanks.
Okay, so for this first session of today, we're gonna debrief of the website with our user support expert, Carmelo. We're gonna debrief of visualization and extraction of data on the Copernicus Marine website. We will continue with Paz Rotlan and Alex Gallardo for the In Situ product debriefing session. And we will finish with Sylvia Pardo from Plymouth Laboratory, Marine Laboratory. We're going to debrief of the ocean color session. So how it works, still the same. This is a debrief session, so whenever you express the need to ask your question, please type your question in the chat platform, bottom right of your screen. Don't forget to enable the question mark. And Josefina and Fabrice in backstage will display the most relevant question for the experts. The experts will begin with 2 or 3 questions you asked during the homework, during the round 2 practical session, or during the webinar session of 29th of September. It will be like a warm-up to leave you time for you to ask live your questions. So please do not hesitate. There is no stupid question. Ask as many questions as you want in the chat. Okay? So I leave the floor to Josefina, who is going to introduce our first lecturer. Thank you and enjoy your debriefing.
Good morning, everyone. Thank you, Vincent. Very happy to be with you again. I hope you all enjoyed practicing with the notebooks. And we start this debriefing session, the first part, with general questions about the CMMs. I give the floor to Carmelo San Marco, who is a Copernicus Marine User Support expert, and who will answer the questions.
Thank you very much. Let's start reading the first question. Can we extract this data with a specific region in mind? For example, a specific region section of a country contained in the dataset, Spain, Portugal, etc. So to answer this question, I can say that yes, for sure, we have like a system especially for the subsetter. So, for example, if I'm going to show you sharing my screen. So we go to the screen. So, for instance, if we go in our product download, and specifically in the subsetter services, we can decide, of course, the bounding box to download. And also, this can be done as well for a single grid point. Just the important things is put the coordinate of the points. The only things is that think to the limited countries like Spain or Portugal. I think that in this case, because we work with the sea region, is not very practical. Is a good question, and for sure there is some sea around each of these country. But I think that it will be is easier divided in sea region, and in fact is what we already do in our catalog, where you actually can search for regional domain. So I suppose that is already done, and I think that works better divide in sea region rather than countries, because we work with oceanic product and no land product. I hope that with this I was able to answer this question. So if we come back now to the presentation. So for the second question, it is possible to download an entire time series as a single netCDF for the min. So to answer this question, I need to say that Siemens have two main products. There is the catalog. So like we can see, there is the ocean product, so the catalog, and the oceanic monitoring indicators. So for the ocean product, yes, for sure, we can download all, like we said before, using the subsetter or other different tools to download, like direct download or FTP, for example. We can download our Siemens data. And after, we can compute them in with the NetCDF that we download, because we need to understand that the product are with a basic structure that is a collection of NetCDF file divided by months, day, hours. So is different for each product. And each product has its own specific characteristic described in the product documentation. So if you are sure about what product to use, and you want a parameter, a mean of a parameter for a specific product, then it's suggested to do it with the specific product, download the specific product, and compute the mean after download the product. So you need to compute it yourself. Another important consideration to do, that Siemens have as well ocean monitoring indicators. The ocean monitoring indicators are very interesting because express global variables, also regional variables, for trend for at least 25 years. So also here, from the ocean monitoring indicators, you can extract, so there is also a catalog for ocean monitoring indicators. You can extract this trend, for example, temperature, about global ocean, for example, or seawater pH. So you can extract this trend, and essentially for each year you can have information about the mean and the general trend across all the years. Of course, the two methods are different because with the oceanic monitoring indicator, the precision is not so accurate like download a specific product and make the mean of the data that you download. Of course, this depends from your research topic, and as well depends from your wish, your precision that you want to achieve, and the variables that you want to have, especially is related to a particular region. And I think that I hope that I was clear answering these two questions. And there is other question that I can ask to. Okay, so OMI are based on,
Yes.
or on, yeah, sorry.
Okay, don't worry. OMI are based on in situ data or models?
Okay, so OMI are a collection, like I can show you on the website. Essentially, if we go in our, because the website is a very good resource, it's very well done, and then is all explained extensively in the description. And is of course the OMI is observation because is a trend of 20 past years. So is of course no data that is modeled, and is a collection of these long data set or recordings, like I said, the minimum 25 years. And it's very interesting to see the evolution of the state of the ocean, and then can be used for many research to improve our resource. Very important that is the ocean around the world. So yes, to answer the question, I can say that yes, are observation, no models.
I wonder if there are more questions. Please feel free to make your questions to the chat. Any question? Nobody is writing, so I guess no more questions.
So let's wait a little bit. People, you're invited to ask your questions. So if you don't have any more questions with our user support experts, we may go to the other debriefing with the In Situ product. Huh? So please feel free to ask your question.
Someone is writing at the moment?
Yes. Okay. For definition, I'm reading.
You have another question, just a clarification. There are OME based.
No, yes, it's correct what she says. I was speaking about the 25 years in the past that for sure are observation, but yes, there is a particular case where in the catalog, in fact, you can find as well a mix between both, depending what you are looking for. In the catalog, I was too simplistic probably, but yes, in the catalog, you can browse and search for also a mix of the two, observation and model. Sorry for the simplicity of the message. Yes, thank you very much for the clarification.
Thank you. Thank you, Carmelo. So
you're welcome.
Just put you another question. So, for example, sea level trends are observation and ocean heat contents indicators are made from models?
No, I mean, it's like a mix of the two, yes. I mean, many, depending on what you are looking for. I was answering just for the 20 years in the past, but sorry, it wasn't my precision. So, yes. There are cases where there is both, of course. And it was my bad that it was no precise.
We have another question. In the catalog, is there some papers where these indicators are used?
Allora, so about that, for sure there is like oceanographic reports where there is like all the achievement in the oceanic science. There you can see for sure many papers and reference to many papers. Now, at the moment, it's difficult to give some title or, but if you browse this section, oceanographic reports, then you can essentially go through these reports and then you will be able for sure to find papers that use this sort of data. Just to give you, an hint where you can search. I hope that, I was helpful.
Let's wait in case we have another question. Someone is writing again.
The important stuff is always search, also if you search for a particular product, also always read the documentation. because for some variables, the products are done in a slightly different way. So depending on the application, is better always search different resources. So like I said, the ocean indicators and the catalog with the products. They set the correct data set, if hourly or monthly or daily. Every research requires different precision and different timing. The next release of the catalog. So to answer this question, I can say that you can search for update and improvements in if product improvements, and then from here, so if you go service and portfolio, product improvements, you can be able here to see all the implementation, all the update, and also the official documentation for each of this implementation, to keep updated about the past improvement and also the upcoming improvement. So from here you can keep really updated about what was and what will be Siemens. Yes. And by the way, recently was released a new interesting service that is very, 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 very fascinating, and I suggest to use. That is like the new viewer, ocean visualization, and is incredible because allow you to see all the products, all the variables that you want and then have a better view of the product, a preview before the eventually download. So yes, I also suggest you to really have a look to these new tools.
Okay, we wait one more second, and if not, we go to the next part of the briefing session.
Thank you.
You have a question here? I need a time series of sea surface temperature with high spatial resolution. Which product to use?
Okay, so to do that, of course, the high spatial resolution, I suppose that here there is no specificity about the region to use, but for example, I guess sample. So in the catalog, the catalog, the product catalog, we can search for domain parameters. So if we go in parameters, we select temperature. Of course, we have like all the products that contain the parameter temperature. Then, of course, from here we can see the resolution of each product. So to check if the resolution that we want. Like we see, there is a total of 52 products containing SCT, and because I don't know what type of region the user was interested, is global or any other regional domain, I can say that yes, for example, this is 1 degree for 1 degree of resolution, while this is 0.083. So for sure, if you want the user want a much better resolution between these two, for example, I will decide this, of course. And then also very important, read the product documentation that is accessible from here, more info and services, because of course is always documentation. It's always good to check all the parameters in which way the data is produced, if it's good for our purpose and the research. So yes, that's all. I would like to ask, for example, because of course there are 52 products containing temperature. So you need also to divide by region, for example. If you are interested in the Mediterranean Sea, for example, in the region, you put Med, and then in this way, at least you have like less products to check with. It's a difficult process because there is a lot of product, a lot of service that Siemens offers. So you need to just read, take your time, and for sure there will be data for your needs. It just you need just to read essentially, spend the time to read all the documentation, and all will be fine. But in any case, please don't contact us, and we are going to help you in any moment, and we are doing our best to solve your issue. So if you have difficulties, don't hesitate to contact us.
We have another question here. Can I use the Motu client with all products of the Copernicus Marine Service?
Okay, so for the Motu client, there is the Motu client works for almost for many products, but not for all. But you can see that very clearly when you go, for example, to a product. So you go in this information tab, you go on services. You can see all the services available for this product. Like we can see, for example, this product, there is no direct file is not available. OpenDAP is not available, but is available, for example, subsetter and FTP. When is available subsetter, then the subsetter works both on the web portal and both in a script way. So we need to the user need to check always that in the service tab of the product there is always a link to the subsetter service. If there are this link here, then the Motu client will be also working. Okay, so for the limit size, yes, is a limitation of the Motu client, but actually is no limitation because help to all the user to download the data. So the limitation is around 1 giga, around 1 gigabyte, but this limitation can be avoided if you use, for example, FTP. Of course, with FTP you download all the data, and then is a much bigger file rather than subset by region or by variables. But is a decision that Siemens did for help of the user to download the data, because download more than 1 giga require a lot of servers power, and then because we have so many users, it's difficult to allow them to send so much request, so big request in terms of data size. But for sure, if you have a specific request, if you need more than 1 giga or you have some urgent purpose, just please contact us, because of course we can also contact, we can ourselves produce some customized data set for your purpose. In case you have difficulties or you have some sort of emergency to have some data and you cannot download in one shot with the Motu client. So always please to let us know, and we are going to be there to help you all to go and to help your research.
Thank you very much, Carmelo.
You're welcome. Thank you to present me.
Thank you. Now we move to the second part of this debriefing session with the questions about the in situ observation products. The experts answering the questions will be Paz Rotlan and Alex Gallardo. You know Paz from the former session, and Alex is a data analyst and software developer at No Login Consulting. So we proceed with the questions.
Yes, the two first one are going to be addressed by Alex. So I leave the floor to Alex.
Hey, everyone.
Yeah.
Hi, Alex.
Can you hear
How are
me?
you?
Fine, thanks,
Yes.
Josephine, for the introduction. I also want to introduce the rest of the IBI team, Marta de Alfonso and Fernando Manzano, that probably they are behind the scenes, supporting us to answer all the questions. And first, Paz and me, we are going to share the presentation, and we are going to introduce the first two questions. We have picked some questions from the initial session in September. I think that probably one of the Manuela is also in the chat now, and he formulated this question in the first session, and what is being done to increase the in situ data, for instance, sea surface temperature or chlorophyll, to improve the satellite data calibration and model accuracy. We are in our team, not only in the IBI region, but also in the rest of the region. We have a constant target to integrate new data from providers in the different areas, and the aim is to increase the available data of the in situ product. But there is not only to want to insert new data, but also to manage new type of platform, new types of data. Path in the training in the Jupyter notebooks has done an overview of the different type of data that we manage in the in situ team, and probably we are trying to improve and to add, to increase the type of data available. Another question that we have picked up. Sorry. Is related with the wave spectra data. This type of data is very new in our catalog, and is probably available from the last year. And we are collecting data from stations that are now providing time series, and we have created a new format for the wave spectra, and you can, as we saw in the dashboard. The dashboard is a tool that Path has developed for the marine in situ team, and we can check what platform provide wave spectra data. And as I said, it's a new type of data recently available, and we have created a specific format for this data. It's available without any restriction now. I give the floor to Pat now to continue the presentation.
Thank you, Alex. I will address the last question we chose from the previous session, and it's the one where Antonio asked who is the one responsible for the integration of the glider data in the system, and I answered it was Coriolis. As you can see, we have an institute for each region that is making the integration of the data coming from the different platforms deployed in that area. But in case of the global networks, the work is done by Coriolis, which is not an institute, but a consortium. There are several institutes behind, and maybe the one you know better is the data center, which is IFREMER. So the answer was Coriolis, and and just providing you the URLs, so just in case you wanna know a little bit more about Coriolis. And that's all. I think we have.
Yes, we have some more questions here, Paz. Please
Yes.
say some words about BioArgo floats data.
We are integrating this data. This is what I can say is something that is has been recently provided for the Argo floats. So that is this kind of floats are reporting very recently also bio data, and we are integrating it again through Coriolis. This is what I can say. So the answer is yes. I was reading it, but I didn't have time to reply through the chat. And one of the exercise we have prepared in the training material, we analyze one of the sailors that had been around the Canary Islands, but these sailors, after being there in the Canary Islands, entered the Mediterranean Sea and end up very close to the Balearic Islands. So I suggest you to run this notebook, because in this notebook you will be able to see the parameter that this kind of platform are reporting. Remember, we focus on checking the temperature, but you will be able also to see if it is reporting chlorophyll, and of course the depth. You will be able to see the depth at which each parameter are being reported. So I would suggest to just run the notebook dedicated to the Ceylon. Yes.
About altimetry product.
Okay, but this
we publish it.
Yes, but the altimetry product is a satellite product, so it's not up to us to reply. Maybe in later intervention from our colleagues from the satellite tax, this question can be addressed.
A question about the depth of the Argo floats?
No, the answer is no. It varies. You can configure actually the depth that you react or you want to react. So it depends on the configuration of the Argo float.
And let's wait, because I guess someone is writing at the moment. Let's see if there is a question for you.
I would like to add that probably it's important that the users check the product user manual, the PUM document, because in that document you can have an overview of all the type of data and the way you can reach all the data set, all the collections, and the way they are arranged and organized in the server. Probably it's a good entry point to our to the in situ product.
Yes.
Here, I was getting some error while running the codes for in situ data.
Can you tell me which error? I didn't see this in Mattermost. I'm afraid I received some questions, but through a private chat, not through the global chat. And this one for sure, I didn't see it. Well, I will check. Apologize because I didn't see it, and I have an alarm set. So sorry, I will check it.
Let's see if we have any more questions.
I also want to add that in the In Situ team, in the IBI In Situ team, we are devoted to our user, not only providers. And if any user have problems to create a data stream, a download data stream, we can support them to create their own scripts and their own data flow, and we are devoted to them.
Anyone asking any more questions? Remember, if the question is similar to another that has been previously answered, don't bother. Just if you have any doubt, do it again, please.
I would like to just say that I'm checking the questions in the chat, so please send it again, Masuma, because I cannot find your question, but just use it and I will reply through the chat, okay? So that anyone having the same doubt can also check the reply. Okay. And yes, I agree with what Alex said. We can also provide support in developing scripts for downloading the data you need if the material we have shared with you is not enough for resolving your own queries. So you can contact us also to request this kind of support. There is no problem.
Yeah, and we will be very happy if we have feedback from the users related with the quality of the data, because sometimes it's not easy to check all the data that we are managing, constantly managing, and sometimes the user can detect problems with the quality control of some parameters of some observations, and it's very useful information for us to adjust our procedures and scripts and to detect some anomalies in the data.
Okay, I guess that's all. So, Paz, Alex, thanks a lot.
You're welcome. Thank you very much.
Okay, thank you. Bye.
Thank you, Paz. And we go to the third part of this practical session with the questions about the ocean color products that will be answered by Silvia Pardo, who is an ocean color scientist at the Plymouth Marine Laboratory. You know her from the previous session. Hi, Silvia, how are you?
Hi, Josefina. I'm great, thank you. How are you?
Fine, thanks.
Okay, so we had a few questions, both during the workshop last week and also on the chat. So thank you very much for those. They were quite interesting. So I've selected 3 of them, which probably were longer and we maybe didn't have time during the workshop. So the first one was made again during after my presentation, and is regarding the atmospheric correction that we apply when we have dust conditions. So I think I touched it briefly during the question and answer minutes we have after the presentation. So just wanted to tell you a little bit more about atmospheric correction. So we did see what happens when the solar radiation penetrates the ocean, but we didn't say anything about what happens when the radiation leaves the ocean and what happens in between the ocean surface and the satellite. So obviously the atmosphere is full of molecules as well. So you have air basically, but you can also have suspended stuff. So that's where the Sahara dust comes in, dust molecules, haze molecules, aerosol like pollution, for example. So the same that happens in the water happens in the atmosphere. So radiation gets scattered and everything. but we only want the signal from the ocean surface. And this is where this question comes in. So every satellite processor has atmospheric correction algorithm implemented. And most of them, as I say in there, rely on the fact that the near-infrared wave infrared signal is almost zero when you have a clear atmosphere or clear ocean waters. So that means that when you have things like an episode of Saharan dust, the atmospheric correction struggles to process that signal and differentiate the signal that comes from the atmosphere and the signal that comes from the ocean surface, which is the one that we are interested in. So for this situation, we need a specific atmospheric corrections, and the one that we use for the ocean color reprocessed data set is called Polymer. So Polymer doesn't have this assumption about the near-infrared signal being zero. It works over the whole spectrum, and it models the surface, the signal from the water as a biooptical model, and then uses polynomial functions to model the atmospheric contribution. So I've left you a couple of links that were on the chat as well a couple of weeks ago with more information about Polymer. So this is the web for the company that developed the algorithm in the first place, and this is the first paper they published. So as you will see, they originally developed it for one of the ocean color sensors called MERIS, but now it works for all the existing and historical processors. And on the next slide, I just wanted to show you a comparison between, on the left, you have the standard MERIS atmospheric correction, and on the right, you have the equivalent Polymer product. So this is a 3-day composite, I think is from March 2003. And you can see all these gaps in the standard atmospheric correction where the processor has masked those pixels because they were affected by, again, things that prevent the atmospheric correction working at full quality, such as sun glint or dust in the atmosphere or aerosols. So you can see that we improved a lot the coverage, but also we improve a lot the quality of the resulting product a lot by using this really specific, really tuned to the optics atmospheric corrections. So that's one of the first questions. The second one was that I found interesting. If you've managed to go through the Jupyter notebooks for the ocean color, I believe in the second one, I suggest an exercise where we see we ended up plotting a phytoplankton bloom from the chlorophyll satellite product, and I suggest that you look at other different variables such as SST and salinity, because as you know, the ocean is a quite sophisticated system. So sometimes the phenomena you can see in one variable you can see in another. So Alejandro posed this really interesting question, asking which SST product he should use for this, and how you will be able basically to plot the SST variable in the same way with a chlorophyll, and see the same kind of a structure, the eddies we were talking about. So basically, as I think we've mentioned today many times, there's a wide variety of SST data sets for this region. I've selected this one because it's a level 4. If you remember when we talked about levels, this means that there's gap-free, and there's a reprocessed data set, and it's also global. So I believe this comes from, this comes from satellite observations for sure, and I believe that this comes at 0.05 degrees resolution. So it's a slightly lower resolution than the chlorophyll one. So what I plotted in here, I posted in here, and I really hope you can see it. Otherwise, I will post the code on Mattermost. Is an example of the code I employed to plot the SST. So you basically define your file, basically, in the same way that we did for the chlorophyll, you use the open dataset function in the X-array module to define the dataset. Then you access different variables. So in here we can access the daily SST, latitude and longitude. You can have a look a little bit. We did this before for the chlorophyll as well. We printed the data set, and that gives you all the information for all the data sets. So for example, if you do this, you find out that this particular variable, for example, is the temperature is measured in Kelvin, which is might be tricky if you're not used to it. I'm obviously more used to degrees Celsius. So what I've done in here is to use a predefined function from the SCPy module to convert from Kelvin to degrees Celsius, and I store that in this variable called daily SST bar Celsius. And then you're very familiar if you've done the Jupyter Notebook exercises, you will be very familiar with this sequence for plotting. So at the end, basically, you end up with this SST map in degrees Celsius for the same day as the chlorophyll map that we had in the Jupyter Notebook. And because it's lower resolution, maybe the structures are not as clear, but I'm sure you will agree with me that you can perfectly identify all this small currents rotating in this direction. So as you remember, what we are seeing here is they're usually called eddies, and they are formed when you have basically a big current, and then there's a mass of water just stretching out of the current because another mass is preventing it. The current is going in the same direction, or you have differences in SST, as you can see, or salinity that makes the water move differently. So that's the second question. And the last question I selected from the chat, which I think is quite important, and I'm sure it's a question that many of you have in the back of your mind, is how can you tell how good the data is, how confident you can be that the values you're seeing from satellite observations are accurate, basically. So I mentioned that on the presentation very quickly. So a big part of the work that we do at the Ocean Color TAC is our quality-related activities. So in particular, we have two ways of measuring the accuracy of the Ocean Color products. That's the offline validation, where we compare the satellite observations with in situ observations. And then we have the online validation. That means that it gets updated every day. And then we compare that data set with the climatology. And that's usually done for the near real time and delay time data sets. So what I've added in here in this slide is an example of each. So basically on the left that you have this example of online validation. So you have your climatology. We explained, I think, the climatology is in the Jupyter notebooks, but basically then climatology means that you aggregate a lot of data during a period of time. So for example, for one pixel, you calculate the mean of all the values in that pixel for the 1st of May for the 20-year time series, so to speak. So at the end, you end up with one value for that pixel that's kind of representative of the value of chlorophyll, for example, in that location. So to create that kind of plots, what you do is you get your daily observation, you subtract the climatology value, and then you end up with a value that you can then refer to the standard deviation of the climatology. And then we construct this histogram. So you have 5 different bins, and depending if the daily observation is between 0, 1, 1, 2, 2, 3, 3, 4, 5 standard deviation of the climatological data set. The short message for this plot is basically the closer you are to the zero standard deviation difference, the better quality the data set is. So here you can see that most of the data are aggregated around -1 standard deviation, if I'm looking at okay. So the colors tells you the percentage of pixels that fall into that thing. And we also pack this information in a quality index variable that we will see in the next slide. And on the right, and to finish, you have an example of the offline validation. So what we are doing in here is that we're using in situ datasets from all these sources that come from different techniques, but we try to keep it simple. So if you know anything about in situ chlorophyll, they are mostly from HPLC measurements. So you have an in situ measurement for 1 day and location. You search for the satellite overpass or the satellite daily product that covers that region on that date. And then you extract the in situ and the satellite data, and then you compare them basically. And we do that using different metrics. So basically, this is the number of in situ measurements, so the number of points basically. You have R or R squared, which is a measure of the correlation. You have phi, capital Phi is the the root mean square error. Then you have a bias root mean square error. Small lowercase delta is the bias, and then you have the slope and the intercept of the type 2 regression. And in the same way as in this plot, the closer to this line, this dashed line, the 1-to-1 line, the better your in situ. Your satellite data is in comparison with in situ data. So in an ideal world, the satellite and in situ will measure exactly the same, and all the points will be on the 1-to-1 line. But obviously, we'll have some dispersion. But in general, the lower the bias or the lower the root mean square error, and the higher the correlation. So our correlation of 0.9 is really good, actually. Tells you that the quality of your data is quite good. And so, as I was saying, for the for the online validation, we also, instead of having this plot, basically, we also have the equivalent maps. So basically, values in the blue and in this gray-white range basically mean that the daily observations in this case is for the 2nd of September 2020 are quite close to the climatology, and the orange and red, that means that the value is quite different from the climatology. So it's just a way of telling that the confidence range might be slightly lower for these particular areas that you have in here. And I think that's me. So I can see plenty of questions.
Yes, Silvia, you have one here.
Yeah.
About the product with size chlorophyll.
Size chlorophyll. Yeah. I don't think I can share my screen. I will share on the chat. I did check the other day because I think someone asked me the same question. I think for the Atlantic region, it will be available in the December release, and it's already available on the global. So you have the chlorophyll, and then you will have different variables called chlorophyll nano, chlorophyll pico, chlorophyll micro. So those are the sizes. But I will write the actual name of the product in the chat, if that's okay. Probably easier if I can't share my screen.
Actually, you can share your screen, Sylvia. Just
Okay.
Next to your mic button, there is a screen.
I saw it. Sharing Mozilla Firefox. Haha. Okay. So let's see. Oh, I was checking at salinity before. Can you see that? Is that okay?
Yes, perfect.
Awesome. So PP and PFT. So this is the one I'm talking about. Let's see if I can find the rep. Level 3 rep. No, where's the level 3 rep? well, we can check at the level 3 near real time. That's okay. So this is the one I'm referring to. So PFT is phytoplankton functional types, which in some cases can be correlated with size class. So this is the one that I'm looking at. I will copy that and paste it in here. And I will stop sharing my screen. Okay.
How could we distinguish the content of ocean color due to oil?
Can't really. I'm assuming that you read the question. I didn't hear you very well, Josefina. I'm afraid I'm not really an oil spillage expert. I seem to understand that it's quite difficult to make apart oil from other substances. The good news is that oil reflects a lot of the light, so it looks like sunglint on the ocean color. So basically the main thing is that as it happened when we talk with salinity, with salt, it's not that you don't have the spectral signal for the substance that makes the oil. That's very well defined. You can define that in a lab. It's that signal is overlapped with other stuff. So as far as I know, it's quite difficult just from ocean color. So what we are using is artificial intelligence, neural networks to say, okay, so this is an ocean color image that contains an oil spill. And we train our system to recognize that rather than exactly have an algorithm that detects the spectral shape of the oil. It's a really good question, actually. It's really, I don't know, state-of-the-art ocean color. It's quite experimental, as I was saying. There are some. Sorry, I've jumped to the next question that says that if it's possible to measure oil spill using Sentinel-2 and 3. Definitely, we have some projects to do that. I will say that yes, with the caveat that you have to train a system to recognize that you are seeing is an oil spill, and it's not, I don't know, because you're in a coastal area and they have been dredging some sediments, for example. So. Another really good question. So we are keeping close tabs, obviously. So from the point of view of Siemens, obviously, it's just another. It's a big deal, but it's just another data stream that we will be incorporating in the multi-sensor product. Obviously, as you know, PACE is just starting. So we are following all the steps. We will be as involved as possible, both inside and outside Siemens, in the qualification and validation of the products. And when we decided the quality of in this case, the rhomboscence reflectances and the chlorophyll is of enough quality, we'll just incorporate it. So on the technical side, we are prepared. It's just basically incorporating a new data stream. On the I don't know, like more management side of the ocean color TAC, we're basically being involved in every conference they have, every meeting they have, every new release. So they are releasing data samples for experts to all over the world. So we are acquiring that and studying them. So we are quite engaged and it's very exciting. Thank you for the question. So I will, again, going back to the oil spillage, I will suggest that first you use, as you say, Sentinel-3, because this is the higher resolution that we have. So at the moment, we provide Sentinel-3 at 1 kilometer. So the first thing I will suggest is that you use the 300-meter files that we will start releasing or start providing from December this year. And the second one is, obviously, we don't have a product for that yet. Because, as I said, it's quite particular. So the best way we can help you is providing you with the turbidity, transparency, and remote sensing reflectances. So obviously, we are quite flexible. So if there's a user requirement to provide, for example, remote sensing reflectances at bands outside the visible, which to my understanding, to some extent you will use for all spillage detection, then it's just a matter of contacting us and see what we can do. I would say that the most advantage you can acquire from using the Siemens catalog is that if you don't use it, basically you will have to acquire your data from different sources. And as I said, for example, all spillage sometimes happens in open waters, but many times happens near coastal waters where the atmospheric correction is quite important. So again, you don't want to hijack, so you don't want to lower the chances of the accuracy of your oil spillage detection by using the standard atmospheric correction, or maybe you don't have the resources to implement or design, implement, and process an atmospheric correction yourself. So that's the main help that we can provide you with. Again, it really depends on the resolution. So right now we are able, we were not a few years ago, and especially because for the detection of eddies, usually you use interpolated data. So at the beginning, we only provided interpolated data for kilometers. So the resolution was too coarse for detecting sub-mesoscale. But yeah, right now it is possible. Thank you for the question.
Let's see if we have any more questions. You have another one on oil spillage?
I would say probably, sure, yeah. I guess it's some, well, you can either contact the user support, so they will, if you want information about the products, or if you're more interested in the science part, I guess my email is somewhere in the presentation or in the material that we provided. So yeah, feel free to contact us for more direct communication. As I said, we have some projects, so we might even working together without knowing it.
Well, we don't have any more questions. My mic has got some echo, they are telling me, no? I'm sorry about that.
Yeah, it's much better now.
Okay.
Like that.
This is magic because I did nothing.
Okay. For the participants, so if you have any more questions, it's time to ask your question in live. The debriefing session is done for that, so do not hesitate to ask your question, or else Josefina will end the session. No more question. Okay, guys, so we hope the expert answered your blocking point or your question. So you have to know that The Jupyter notebooks and the Jupyter Hub will be open for during 1 year, so you have plenty of time to practice. One more thing, you will receive a thank you email and an email to register to the debriefing of tomorrow. Tomorrow we are debriefing on bio products, physical product and wave product with Alvaro Pascual, our experts. So if every participant, so there is a last question, will you provide any certificate? For each session you have an automatic certificate coming to your email, so yes, we will have certificates. So Josefina, have you got anything else to add for the participants?
Yeah. Only thanking the experts and the participants. Thank you to be here with us today. See you tomorrow at the same time.
Okay, guys. See you tomorrow. So have a good day. Bye-bye.
Bye.